Hello, welcome again to our third week of 577. Today we're going to start the scientific process, and I hope that you got a chance to read and do the work for chapter 1, which was more of an introductory to what is the expectations of the research process. And actually I looked at your work, and I still need to give you the feedback. So this will be the work that I'm going to do this week while you guys are venturing on chapter 2. I wanted or I'm hoping that you will start today with first reading the chapter. As I always say, please read the chapter as the first step of the week, which is on Tuesday. Then maybe tomorrow you are ready to view this video. If you finish today reading the chapter and then you found the video available for you, you can go ahead certainly and start with it. The video usually is complementary to your reading. It will guide you through the process of what you need to do next, and make sure that explains everything and lectures you about the concept behind chapter 2. In chapter 2 was mainly about identifying the research problem. That's the first step in conducting a research, is to find what is it that I want to research. And this question of what is it that I want to research is finding your research problem. I have a PowerPoint for you here that summarizes and condenses again the information that I want you to make sure you understand about understanding and identifying the research problem, and then the steps when you decide on your research problem. First, I'll go to the first slide here, which is what is the difference between a research problem and a research questions, because many of the students confuse between, when I ask them what is your research problem, they go ahead and right away jump into telling me the research question. Whereas the idea is, the problem is just finding out what is it that you want to research. And then the research problem comes in to complement this idea or this problem with breaking it down into questions. You can have one question that targets the problem right away, or you can have two questions with a subcategory question that focuses specifically on one part of your problem. It really depends. You can have 3 sets of questions that stems from the problem, because the problem can be an idea that cannot be explained in just, or cannot be researched as a bulk, but rather into categories. These categories are your research questions. So here I explained to you both what is a research problem and what is a research question, in order to make sure that you understand the difference between both. A research problem, and it's just the topic that you like to address and investigate or study. Just telling me the phenomenon or the topic that you want to research, versus the research question is the way that you will express your problem or your phenomenon based on the necessary ways of exploring this problem. What are the problematic aspects? You're highlighting the problematic aspects in this problem in order to break it down and research one at a time. I want you, when you finish reading this slide on your own carefully, and I just explained it to you, but I would like you to read it carefully. I want you to look at, if you go to Blackboard and you go to your course content we're in week 3, so open week 3, and you find specific things that I want you to know. First is building these questions and how you define your research questions. So let me read this for you first, and then we'll look at what is an example, a good example of a research question, and what is not a good example of a research question. So in here is defining and writing the research question. If you open it, basically what makes a good research question? So we said that you have your problem, you have the phenomenon that really interests you or brings some curiosity to your mind, and you want to research it. You want to make the question that matches with this problem. Well, what makes a good research question in order to be sure that I'm doing the right thing? It's a common query that the graduate students face when developing their research topics. Unless a topic and its subsequent questions are handed to the student, there is often a period of uncertainty, and I had many students struggle in this phase and stay forever because what we call as educators reinventing the wheel. This is the problem, and this is the issue that many graduate students fall into, which is the idea of, oh, I want a new idea, I need a new concept. No, you don't need to do this when you're doing your thesis or even your dissertation study. All what you need to think of is a problem that concerns or interests you, and then think of how was this topic tackled in any other researches, and build on this idea and this interest research questions that are not complicated. Do not try to reinvent the wheel. Do not try to go and write questions that no one had handled it before, because you leave yourself going into loops trying to figure it out. So they go into long period of uncertainty in which the student is developing a host of possible research questions, all the while wondering if they are actually thesis or dissertation worthy. Students often feel they need to demonstrate their sophistication by creating complex and multi-layered questions. Don't do that. Certainly, it's important to consider the originality of a research topic, the contribution it will make to the field. Absolutely. Think of how are my questions are unique. How am I contributing? However, you need to make sure that you have other researches that you are really basing your ideas on. So when you have a curious concept or problem, start to research it. See how it was tackled. Then once you have some sort of an idea, start to shape your unique questions, because you're the one who's creating it. And I'm sure that no one wrote this one before. So you're creating it, and that's its uniqueness right there. But then it's based on some sort of substance. Something happened before, someone tackled it, but you're adding a little piece of yours, your touch, right? Don't be too complicated. Don't have multi-layered. Have a straightforward question with no complexity. You can approach an interesting and important topic with research questions that are uncomplicated and clear. Start with the idea, what you want to know about the topic, and then break the idea down into more and more precise questions. Don't be afraid of simplicity in composing research questions. A set of straightforward research questions will help you stay focused. All right, so that's one thing or one way to think of your problem and how you can venture into writing your research questions. Now, the other thing that I wanted you to look at is, what is an example of a good research question then? And what is not an example of a research question. Here you have this document. If it opens, see, here we go. And a good example of a research question: do students in Algebra 1 classes who engage in the XYZ curriculum performance significantly differently do differently on state tests than students who do not participate in that curriculum, that XYZ curriculum? Do these students perform significantly different than these students who do not participate? Why do students seem so apathetic? Now look at the difference between these two. This one is good. It is specific and clear, right? You have 1 and 1, and you're comparing these two and how the students differ from this group than the other group in their performance. You named every specific thing: the algebra curriculum, students, their performances, this is what you're measuring, and then the difference between the curricula, right? Versus this one, this is not specific or clear, nor does it reflect an intervention. What is the intervention? What are you trying to test here? Why do students seem apathetic? Well, and then I can go forever, right? But if you're comparing, or if you want to talk specifically, why do students seem apathetic when they do this at this time? That's more specific and more clear into what are you trying to assess, who are you trying to assess, and when exactly. What are the variables that you're trying to assess? And this is one of the terminology that we tackled here in this chapter. So, nor does it reflect an intervention if one is planned or a target group of participants. Better questions might be like, are science students more engaged in class discussions when a response strategy is used? Okay. What are the reasons for apathy among various groups of high school students, either experimental or descriptive? Do you see the specification of the students, the group age, the population, the environment, the setting? Everything is specified. That's a good question. Please read through the good questions versus the bad questions in order to exercise and train yourself into how can you form a good question. All right, now let's go back to our PowerPoint. So determining whether a problem should be researched or not. When you decided your problem and you're starting to write your research questions, you'll have to put in mind, is it worthy? Is this problem and are these questions bringing something different to the table, something new to the table? That's another question that you need to ask yourself while you're writing it. When you write the questions, try to experiment. Can you study? Are these questions good enough? Can I study this problem? Do you have access to the research site that you're talking about? Do you have the time, resources, and skills to carry on? Should you does it advance knowledge in this field? What is the purpose of studying this topic? Am I benefiting others with this kind of information? Does it contribute to the practice of our field? Will you study, fill a gap? Will your study replicate a past study but examines different participants and different research sites? So when I say not reinventing the wheel, you can actually look at a study and think, look, and then think, well, how about this population? Or how about this age group? Or how about this culture? Okay? Will your study extend past research or examine the topic more thoroughly? Will your study give a voice for people who are never heard, different ethnicity or different culture? Will your study inform practices when teachers decide to do something? When they read your research, does this make a difference in their practices in the classroom? After you find the problem, you wrote your research questions and you examined your research questions, you need to now start writing your problem statement. The chapter in the book here gives you excessive information on how to write the statement of the problem or the problem statement. And in here, I'm just giving you bulleted points in order to have it like a checklist next to you when you're writing your problem statement. Is the statement clear? With the problem stated at the beginning of your statement, evidence that support the existence of the problem, you need to discuss with me, why is this a problem? You need to convince me that this is a problem. So you first talk about the problem, convince me why is this a problem, how it exists, evidence with examples, define the major concepts and terms that you're going to talk about in your research, describe the people that you want to explore and research, describe the setting, tell me about that setting that you're going to. So this clarity and these details tells me more about the problem and how or where, which points are you tackling exactly. So this way, when the person reads or when a reader reads your research questions, your problem statement and research questions, it starts to make sense. Oh, okay, well that's really a good research. I decide whether this is a good research or not by looking at the statement of the problem and the research questions that this researcher talks about. So in any research, you'll see this introduction that tells me more about the topic in general, and then the statement of the problem that tells me about the problem in details with specific details about who are you studying, why are you studying it, all the necessary details, and then you tell me the research questions that I'm going to look for when I get at the end if they were answered or not. This is a visual of what I just talked about, the flow of ideas in your problem statement. You'll tell me about the topic itself, the educational issues that you're targeting, evidence about the problems, deficiencies in the evidence, whether it was tackled before, it was tackled but there wasn't anything about this population, or it was tackled but there wasn't anything about the psychological effect of blah blah blah. So what are the deficiencies that you're going to tackle now in this research? And then who are the audiences? Who are you actually looking to target this research for? Are they teachers, policymakers, practitioners? Who are you talking to? Who is it going to benefit, basically? Then we come to some of the important terminologies that you need to understand and make sure you know when you are thinking of your problem and when you are writing your problem statement and when you are shaping your research questions. Some of the terminologies or concepts that were tackled in this chapter were the word variable, constant, operational definition, hypothesis. These are the terminologies or the concepts that I thought might be new for you. I mean, the whole concept might be new, but these terminologies are important in order for you to understand what you're doing, intentionally writing these things. So a variable is the property associated with the concept that varies when measured. So when you say you want to see the algebra students that take this curriculum AYZ, XYZ, if they do better, significantly better in exams versus students, algebra students who do not take this curriculum. The variable here is the curriculum, the AYZ curriculum, right? Someone who takes it and someone who doesn't take it. It's called variable because it's a changing situation, right? But if you talk about the science class, you want to see how the students react to a specific strategy, teaching strategy in a science class, and you can call it AYZ class, but you're only looking at these students using this strategy. Then it is not changing. The property is not varying, it's not changing. You're looking at African American students who are learning science through cooperative learning. Okay, this is your research question. That's just a mere example. Okay, then this strategy is constant. There is no changes. Your students are the same. They're not changing over the course of time. You are not comparing one ethnicity to another, and you're not comparing one strategy to another. You're just studying this strategy with these group of students. So that's a constant property of your questions. Then there is this operational definition. The process or the steps we use in measuring variables is called the operational definition. When you tell me you're going to do the implementation itself of the research, you're going to do this first, then the students will take this test, and then you'll start with the strategy by doing this and this and that, and the students will work independently, then work cooperatively. All of these specific steps in how you started the research and how you're going to end it, and how are you selecting your students, and how are you operating the whole research process is what's called the operational definition. Because the importance of this definition or defining the process of your operation of the research is important because you want to help others to build on your research. If another student comes after you finish your research and wants to tackle this research from a different perspective with different ethnicity group or with a different strategy, they can use your research as their literature review and build on it because they have the operational definition. They know how you did it. But if this part is vague, no one can extend on your study and no one can use your study as a source of knowledge because they don't know. Things are ambiguous or things are vague, so they can't build on it. So without this operational definition, no one can build on it. So first you need to understand, what is a variable? Do I have variables or not? And you can actually identify your variables. Or you can say this is a constant variable where nothing is changing and nothing varies in the process, and you can or have to explain to us the operational definition. You usually do this throughout the research paper. You probably explain a little bit in the statement of problem, but you heavily do this in the methodology section, basically, where you tell me more about the participants and how are you going to start and how are you going to finish. And we're going to learn about this more in module, I think, 3. The fourth term is hypothesis. What is a research hypothesis? You will not hear this word research hypothesis if you are doing a qualitative study. But if you are doing a statistical or survey or quantitative research, you find that you'll have to put hypothesis. And hypothesis, the other word for hypothesis is predictions. So you identified the problem, you wrote your statement of the problem, you wrote the questions, but under each question you have to have specific few bulleted points or one bulleted point under each question to explain, well, how do you think or what do you think is your prediction or your hypothesis for this question? What do you think will happen, or what do you want things to end up happening? Okay, so essentially it's a declarative statement of how you expect the research to turn out. In a way, it is a possible answer to your research questions. When you do the results at the end in that type of research, you are actually going to identify your hypothesis and say if it's significantly matches your hypothesis, the results and the numbers significantly match your hypothesis, the results, or they significantly do not match at all, or there is a level of matching. When you say a null hypothesis, it means that there was no matching at all. This is here an example. So if you say, do students in Algebra 1 classes who engage in the XYZ curriculum perform significantly different on state tests than students who do not participate in that curriculum? Possible hypothesis, you can say students who participate in this curriculum in algebra will perform significantly different. And the word significantly, I highlighted it with a different color because it's a typical word that you use in a research, a quantitative research or analysis, analytical research, surveys, anything that has to do with statistics. You have to express it with the word significantly, because significantly erases any doubts from your statement. When I say significantly, I mean it's completely, it's holistically different on state achievement tests than students who do not participate in that curriculum. If one wanted a directional hypothesis, one also could have written that the target students will perform significantly better on the test. This is a directional hypothesis. When you predict that the research will take one way different than the other, and you want to prove that. When I ask the question, do general education teachers evaluate students' homework differently than special education teachers based on 5 criteria? Look at this. This is how specific this question could be. Sorry, I have a sensor. The sensor closes the light if I wasn't doing a lot of motion. Okay, let's see. Hope you can still see me. I just can't see the screen for some reason. I know that the video must be still working. It seems like I can't see the screen for some reason. I'm not sure if you can see it either. Oh, here we go. Everything just froze, huh? Okay. So let's see. Oh. Must be some sort of a power problem in my office here at work. Okay, as you can see, the screen is freezing a little bit, and I'm hoping that it's still video recording. We don't want to start all over. But what we were talking about is the different kinds of hypothesis, and the directional hypothesis is more like the hypothesis, oh here we go, more like the hypothesis that gives a specific direction towards a specific, a particular kind of result. higher than, better than, rather than just they will do well, or it will be significantly different, and you'll stop. No, you'll say that it's better even. When you go to this question about the evaluation and see how specific that was, the based on 5 criteria, this is a specific good example of a good question. The possible hypothesis that you can choose is general education and special education teachers evaluate students from homework significantly different on each 5 given criteria. You can go directional and say they use it more. One group use it more, use the criteria more than the other group, or you can just say that there will be significant difference. Or you can say the null hypothesis. When you hear the word null hypothesis, it means that there was no results. It is simply a statement of saying that you expect no difference in the outcomes between both groups. So null means zero differences, or whatever that you're trying to measure will be zero results that you're seeking. So directional hypothesis and null hypothesis. These are the 2 kinds of hypothesis that you'll have to state when you are discussing or stating your hypothesis for each question. You don't need these. I think it was just done by mistake when I was trying to get it to work. Okay, the next slide. I think that was it. These are the terminologies that I wanted to discuss with you, and I wanted you to understand that it's a process. Finding your problem, writing your problem, and then writing your questions, and maybe or maybe not having the hypothesis. All of these are an interactive process, all together merge into one at the very end. So you don't come with your problem right away. Your problem keeps developing throughout the process. Even people find it throughout the process of writing. But it's best, of course, that you decide on your problem and read more from the literature to decide on the aspects and the details, then start writing your problem, which will help you to focus and narrow down your ideas even better. And then when you write your questions, you'll force yourself to be even more detailed, thinking about your variables, your constants, and your operational definitions of every single detail that you're going to do. You're going to think about your hypothesis when you're answering or thinking or predicting what could be the results for these questions. All of this is a process that will help you kind of shape your first step towards writing a good research. So it's a process. It does not happen all of a sudden, and you don't have a decision made right away. That's why I decided to have you think of your problems last week, and then today or this week you are going to reflect on your choices of your problems and your research questions. You have the questions now ready under the discussion board, which is mainly narrowing, reflecting on your research questions. So please go there and revisit and answer the questions again, and think after you read my comments. I'll give you comments on your previous notes, and I'm sure that your colleagues did too. And then you read this chapter this week, thought even more, maybe got a chance, or I hope you get a chance to look at some literature, just read a couple of research that tackles the same problem that you are thinking of, and then by the end of the week, please re-answer, reflect on the questions and the problems, so that you'll have more of a solid idea now to move us forward to the next module, okay, which is writing the literature. I hope that you don't have questions here, and if you have questions, please raise them under the discussion boards, or you can email me if it's something that concerns you personally. But if you have a question for the greater good on shaping your questions or problem, ask that in that thread that you're going to post on your problems and your problem and your questions. It's best that you go to research articles on library articles versus Google, because it will give you more authenticated and more peer-reviewed articles that are solid in their background and who wrote it and the author and all of that. So it's more trustworthy. But if you don't have any resource to the library, I have a link on Blackboard that you can use here that says library. You can enter here. There's no internet connection for some reason, but if you, I think because of the power outage that we had a moment ago, if you go there, you can type in the topic that you're trying to research, and then you can post it. You can find more ideas to help you to shape your problem and your questions. That's the lecture for today. We discussed what is a research question, the difference between a research question and a research problem, how to write your statement, what are the important terminology that you need to know, major concepts in writing a research questions, and then the flow of your writing. I think there was one thing that I wanted to show is this difference. So this is your general idea. It starts there, right? And throughout this process, you get to identify the specific. Like I just explained to you, you have the topic right there. You kind of research the problem through literature and through readings, which brings you closer to your problem statement, gives you an idea of why and who and where are you researching this problem, and you're going to write this, and this will help you to shape your research specific narrowed research questions. And if you will need to do the hypothesis, we'll wait a little bit on the hypothesis. Don't do the hypothesis now because you don't know which kind of research you're going to choose. On module 2, we're going to discuss the different or module 3, I can't remember, the different methodologies of research. So if you decide at the end to do a quantitative, then you'll need the hypothesis. If you're going to do a qualitative or an ethnographic, you don't need hypothesis because it's built on merging themes rather than knowing or expecting what might happen. You just need collecting data and numbers. In qualitative, it's all emerging because you cannot predict human reactions or perspectives. But in quantitative, it's all about numbers. You're going after the numbers to prove a point or not, or to find that it's not proven if it's null hypothesis. Okay, hope this helps. Please feel free to ask me any questions, again, either through Blackboard or email me, and I hope things and communication is going smooth now that we have the video and the screen capture. Good luck this week and wish you the best.